All right, today we're going to go over exponent rules. So that's our learning goal, is I know and can use exponent rules. So we're going to kind of try to discover some of these. So let's do a little bit of vocabulary. The 5 right here is called the base. It's what's being raised to the power. Excuse me. And then the 4 is the power of the exponent. That is how many times you're going to multiply the 5 together, right? 5 to the 4th is 5 times 5 times 5 times 5. By the way, when you write it out this way, it's what we call expanded form. Okay, so this one's written as with an exponent. This is an expanded form. What we're going to do is take some of these problems and write them out using expanded form. So let's start this first one right here. I have 3 to the 4th times 3 squared. We want to write it out in expanded form. So that would be 3 times 3 times 3 times 3. That's 3 to the 4th. And we're multiplying that by 3 squared. Okay, we get done there. We'll just count. How many 3's do I have multiplied together now? There, now. I've got 4 and 2. So all together I have 3 to the 6th power. Go ahead and do that with the 10 squared and times 10 to the 5th and the a cubed times a to the 6th. You can pause it. Just pause the video real quick and work that out. For this one, you should have ended up with 10 to the 7th. And for this one, you should have ended up with a to the 9th. Now, we don't want to have to write it out in expanded form every time. So we want to come up with some shortcuts. So this is what I want you to do next on your paper there. I want you to write a general rule about exponents that summarizes the problem above. So pause the video, come up with your own rule, and then come back and I will let you know what mine was. Right, so if I were writing a rule for this, I would say, if I'm multiplying things to the same base, for example, these 3's, the base stayed the same, and I added the exponents. So I added the 4 and I added the 2, so 3 to the 6th. Right, the 10, base 10, base 10, they have the same base. When I multiply things to the same base, the base stays the same, and I add the exponents, 2 plus 5. If I have the same base, a and a, base stays the same, I add the exponents. Okay, so something to that effect. This is how you could write it algebraically, is if I have something raised to a power multiplied by the same base raised to a power. The shortcut way of doing that is you keep the base the same and you add the exponents. I have a couple of examples here. We're not going to do them all, but we'll pick a couple of them. Let's do number 1. Okay, so we want to multiply these together. One thing to remember is that multiplication is commutative, which means, and that's all just a big multiplication problem, right? That's 3 times h squared times 2 times h to the 5th. Is with multiplication, you can rearrange it. So I can write it this way, 3 times 2 times h squared times h to the 5th. Okay, when I multiply that out, I get 6, and h, the base stays the same. I add the exponents, so h to the 7th. That's really as far as I can simplify it. You guys try 2 and 3. Pause it. Try 2 and 3. I'll give you the answer so you can check it in a second. And then we'll do number 4 together. So go ahead and pause it and work on those 2. So number 2 should have ended up being 6x to the 3rd, y to the 6th. Number 3 should have ended up being, right, there's just one a. You add the exponents of the b's, b to the 8th, and add the exponents of the c's, c to the 8th. Okay, let's do 4 to get together. So I've got all 3 of those. We can just they're all just multiplied to get together again. So we can just rewrite that as being 5 times 2 times x to the 3rd times x to the 3rd times x to the 5th times y to the 4th times y squared. Okay, now we can multiply those 2 together. That'd be 10. Even though now I have 3 x's, they're all multiplied together, so the rule still applies. Just keep the base the same, and I just add all of their exponents. 3 plus 3 plus 5, so adds up to be 11. Y. Be careful here, that's y to the 1st. If it doesn't have a power, it's a 1 there. Add up the exponents, 4 plus 1 plus 2, adds up to be 7. So it's simplified as far as we can take it. All right, let's see if we can figure out this next rule. So I have 4 to the 5th squared. So let's write it out in expanded form. 4 to the 5th means to multiply 4 together 5 times. And then I'm squaring it, so I have to multiply it by itself. So I'm going to multiply it by itself. So I've got 4 to the 5th times 4 to the 5th, which is the same as 4 to the 5th squared. So now I have 4 to write it with a single base, so base 4, and just count how many are multiplied together. There's a total of 10. Okay, you go ahead and try that for x to the 3rd to the 4th and y to the 5th to the 3rd. So pause it, write it out in expanded form, and then write it with a single base after that. So just to check that, this should have ended up being x to the 12th. You had 3 x's, 3 x's, 3 x's, 3 x's. Altogether, you had 12 x's. This should have ended up being y to the 15th. You wrote out a lot of y's. Okay, so if we want to write a general rule about exponents that summarizes that, is if you have parentheses, right? If I have something raised to a power, a to the m, and I raise it to the nth power, the base stays the same. It's still a, but we multiply the exponents together. So we go m times n. Okay. So this is a little bit different. Don't mix it up with the last rule. The last rule is if you multiply things with the same base, you add their exponents. This one is if you have a power to a power, then you multiply their exponents. Hey, here's some examples. Number 3, I got x to the 4th to the 3rd. So the base just stays the same, and we call this a power to a power. I have x to the 4th to the 3rd, a power raised to another power. The rule is we multiply them. That's our shortcut. You guys pause it, do 6 and 7, and then we'll do 8 together. For 6, you should have ended up with 5 to the 10th. Make sure you don't change the 5. It's the base. It stays the same. This should have been a to the, let's see, 12 times 9. You wouldn't want to write all those a's in expanded form, right? That would take you a while. What is that, 908? 8 I wanted to do together. You're combining a couple of rules, like we're multiplying. Those are multiplied together, but we also have this power to a power. Remember, exponents come first, so I need to simplify that before we can multiply it. So I have 3b squared times by, and b to the 3rd to the 3rd. That's a power to a power, so the base stays the same and I multiply them. This would be 3b, and add those exponents up. 2 plus 9 is 11, so 3b to the 11th is what that works out to be. Okay, next rule. If I have things on the inside that are multiplied or divided, we want to see what happens. So let's do these together. Xy to the 3rd means xy times xy times xy. So if you count up the x's, I've got 1, 2, 3 x's, x to the 3rd. I've got 3 y's, y to the 3rd. This next one, same thing. I've got 2 times x times 2 times x. And I have to do that 4 times because it's to the 4th power. So all the 2's, count the 2's. You could multiply those together, but let's just write it with a single base. So it'd be base 2, and you add all those up. So you end up with 2 to the 4th. X's, same thing, x to the 4th. This next one, I've got x squared y times x squared times y. Okay, so remember our rule. If I have x squared times x squared times x squared, the base stays x, and I add up those exponents. So 2 plus 2 plus 2. That's that first rule we did. And then the y to the 3rd power. So those were all multiplied. This last example, we're dividing. So if I have 2 over 3 times 2 over 3 times 2 over 3. So remember, we just multiply the top together and the bottom together. Let's keep it written as a single base to the power. So this would be 2 on top to the 3rd power. There's 3 of them, and 3 to the 3rd power. So if you look down through that, what's happening here, right, is this power, as long as you're multiplying or dividing, this power applies to everything on the inside, right? That 4 applies to everything on the inside. That applies to everything on the inside. So if you're multiplying or dividing and it's raised to a power, you can take that power and just apply it to everything on the inside and use that. That's another way we can simplify problems that involve exponents. Okay, we're almost there. We've got one more rule, then just one more big rule, a couple side ones. So let's use our rule to do this. Hey, number 9, this is we make a lot of errors on this. So the rule said if those are times together, which they are, the 3 applies to both bases. So I have 2 to the third, and I have y to the third. Don't forget the 2. A lot of times you raise a y to the third power, but we forget about the 2. Hey, we can simplify this. 2 to the third, 2 times 2 times 2 comes out to be 8. You guys try 10. Pause it and try 10, and then we'll check our answer, and we'll go through 11 and 12. So on 10, you got to go 4 to the third. Now this is a little bit tricky. I have to go x to the third to the third. That's a power to a power. We multiply them, so x to the 9th. 11, a squared squared times those, power to a power, b cubed squared times those, b to the 6th. Okay, 12's combining rules, so I'm going to leave this alone at first. I need to simplify this first because it has a power on the outside right there. Do not forget to raise 2 to the power. So that'd be 2 squared, x to the third squared, that's x to the 6th, y squared squared times those. Okay, now we can multiply them together. So the 2 squared is 4, 4 times 5 is 20, x squared times x to the 6th is x to the 8th. Y to the first times y to, make sure always if there's not a power you put a 1 there. Y to the first times y to the 4th is y to the 5th. Okay, that's as far as we can simplify it. So that's combining a couple different rules. But just remember, if you have parentheses, the power on the outside, as long as you're multiplying or dividing on the inside, that power applies to everything on the inside. Okay, division. Let's write this first problem. I have 5 to the 9th over 5 to the 6th. Let's write it out in expanded form. It's going to be a lot of 5s. How many I got there? 6, 7, 8, 9. Okay, on the bottom I have 6 of them. Okay, and we talked about when we did fractions that if you have a common factor on the top and the bottom, they can reduce down, or we could say they cancel out, but they reduce really. We have a lot of common factors, right? The top has 9 factors of 5, the bottom has 6. So let's cancel, let's reduce those. That would be 1, 1, 1, 1, 1, 1. So if I want to write that in reduced form, or write it with a single base, I'm going to write it as being 5, and we have 3 left over. Okay, 5 to the third power. You guys try it with that next one. We're going to skip this, so don't worry about doing that bottom example, but try that x to the third over x squared and see what you end up with. That top one should have been this, right? The bottom one should have been this. Reduce it. You're left with x to the first power. Okay, so again, we want to come up with a shortcut way of doing this. So our rule on this one would be, right, if I have things with the same base 5, and we're dividing, you keep the base the same. It's still base 5, but you subtract the exponents. Right, I've got x to the third over x squared. Keep the base the same and subtract the exponents. Let's write just a generalized rule for that. So we'd say this. If I have a to the m over a to the n, they're both raised to the power. The base stays the same, but you subtract the exponent. Okay, 2 really quick ones. Oh, I'm sorry, I have a couple practice problems here. Let's do that really fast. You guys try 13. Pause it, find the answer, and then we'll check it. The rule, right, is the base stays the same. You subtract the exponents. So it's a to the 4 minus 2, or a squared. Okay, on 14, I want to do this one because you see the 3 and the 6. If you have numbers in front, you should just treat that as if it were a fraction and just simplify it. So the 3 over 6 you can reduce. Divide them both by 3, just like you would on a normal fraction. It could be 1 over 2. And now I've got x to the 5th. Now we're just going to do this part right here. X to the 5th over x to the 1st. Okay, they got the same base, so the base stays the same. By the way, you always put the base on top of the fraction if there's a fraction when you use this rule. And now I subtract their exponents. I go 5 minus 1, which is 4. So you could leave it like that. You could write it as 1/2 x to the 4th, or you can write it as being x to the 4th over 2. Either one of those is fine. So on 15, just reduce that part. 25 divided by 5 is 5. do the c's, that's c to the first. So the base stays the same. Subtract their exponents. 3 minus 1 is 2. The d's stay, you got the same base, keep the base the same. Subtract the exponent. 6 minus 3 is 3. And that's the simplified form. On 16, the 7 over 49, right, that doesn't come out to be a whole number, but we can reduce it. 7 divided by 7 is 1. 49 divided by 7 is 7. So just simplifying a fraction like we've done. So there's my fraction. And now I'll work down through these. X to the fourth over x to the third. That would be the base goes on top always. You subtract the exponents. 4 minus 3 is 1. Now this one's kind of interesting. I have y to the first over y to the first. So keep the base the same. If I subtract the exponents, it comes out to be 0. We could also think of it this way. If you have y over y, really just reduces down to be 1. So we're going to talk about this, but y to the 0 is actually the same thing as 1. Okay, it means the same thing. So if you're timesing by 1, it just goes away. You end up just with 1x or x over 7. You can simplify it all the way down to there. That's a little bit tricky, but we'll do some practice with that. Anyway, the last two things is talking about 0 exponents and negative exponents. There's a pattern to these. I just want to show that to you. Hey, 2 to the fourth is 2 times 2 times 2 times 2. That comes out to be 16. 2 to the third is 8. 2 squared is 4. 2 to the first is 2. So look at the pattern here. Every time my exponent drops, we're dividing by 2. Well, that means 2 to the 0, right? If I go 2 divided by 2, 2 to the 0 comes out to be 1. Hey, that's our first rule. If you have something raised to the 0 power, it's always 1. Like y to the 0 came out to be 1. 2 to the 0 came out to be 1. Now we want to keep going and figure out what happens with negative exponents. So if I divide by 2 again, right? If I take 1 and divide it by 2, I end up with 1/2. If I kept going, 1/2 of 1/2 is 1/4, which is really 1 over 2 squared. If I divide by 2 again, I get 1/8, which is really 1 over 2 to the third. So that leads us to our next rule. If you have a negative exponent, 2 to the negative 2, you can actually take it and flip it over. You can take the reciprocal, and it becomes a positive exponent. So let's do a little bit of just practice with this. Let me go back here. Let's write down those rules. So the first rule is, these are the last two. A to the 0 is equal to 1. Anything to the 0 power. This next rule is, if you have a negative exponent, you can take the reciprocal. You can take the reciprocal and make it a positive exponent. The rule for negative, one other thing with negative exponents is if you have this, if you have something raised to a negative exponent on the bottom, you can take it and move it to the top. So it goes both ways, go both directions. Let's run through these quick examples of zeros. It's kind of interesting. 4 to the 0 is 1. Because this is in parentheses, that 0 applies to the negative and the 4, so it would also come out to be 1. Now look at this problem. There are no parentheses, so what that means is the 0 only applies to the 4. So the 4 to the 0 comes out to be 1, but there's still that negative in front. So you got to be really careful. If the negative applies to everything, the whole thing changes to 1. But if it doesn't, if there's no parentheses, it only applies to what it's next to. So down here, the 0, that applies to everything in the parentheses. That whole thing changes to 1. But on this problem, the 0 only applies to the x, so only it changes to 1. So you'd have negative 4 times 1, which is negative 4. So you just got to be really careful. Whatever the negative applies to, whatever the 0 applies to is what you're going to change to 1, but nothing else. Okay, just a quick review of the rules. We're going to skip the example part. We just did a bunch of those. But the rules are this. If you times things with the same base, keep the base the same, and add their exponents. If you divide things with the same base, keep their base the same, and you subtract their exponents. If you have a 0 power, it always equals 1. If you have a negative exponent, you always take the reciprocal. If you have parentheses like that one, x times and their times are divided, then the n applies to both of them. And last two, if you have a power to a power, x to the n, you multiply the exponents. If you have a fraction, that really goes with this one up here. right? If you're multiplying or dividing, that m just applies to both of them. X to the m over y to the m. So those are your exponent rules. I have some practice for you. Do your best on those. I'll show you the answers. Plus, you can send me questions if you have them. These are tricky and they require some patience. So be patient with it and do the best you can. Thanks, guys. Appreciate your attention.